Hello, this is Ms. DB, and in this lesson we're going to learn about multiplication properties of exponents. This is from Chapter 7, Section 3. So our objective is to use multiplication properties of exponents to evaluate and simplify expressions. We have already seen that exponential expressions are very useful when we write very small or very large numbers. To perform operations on these numbers, you can write them out in expanded form, but there's a shortcut, which is the properties of exponents. And we can also use these properties to simplify our answer. So we're going to learn some of the properties that will help us simplify exponential expressions containing multiplication. In the 7.4 lesson, we will learn about division properties of exponents. So in order to simplify an exponential expression, these are our rules. First of all, there should be no negative exponents. Second, the same base does not appear more than once in your problem. No powers are raised to powers, no products raised to powers, and no quotients raised to powers. The numerical coefficients, those are the numbers in front, do not have any common factor other than 1. For example, these are all simplified. B over A, x over 3, B over A, x to the third power, z to the 12th power, a to the 4th times b to the 4th, s to the 5th over t to the 5th, 5a squared over 2b. All of these are examples of expressions that have been simplified. Some non-examples of exponential expressions are in the second box. For example, a to the negative 2. That violates the rule that there are no negative exponents. And then ba. The second one is x times x squared. This can be simplified. This violates the rule of the same base does not appear more than once. The next one is z to the third to the 4th power. That's no powers are raised to powers. Can't have that. You've got to simplify that. The next one, AB, all raised to the 4th. That's a product raised to a power. And then this next one is S over T to the 5th. That's no quotients are raised to powers. And then finally, 10A squared over 4B. Both the 10 and the 4 are divisible by 2. So that could be simplified to 5A squared over 2B. Now we're going to learn today what to do in these 4 different situations. This one you already learned about. You learned that a negative exponent, you can drop that down to the denominator, and then we would still have to simplify the a to the 1 and the a to the 2 on the bottom. We'll learn how to do that in the 7.4 lesson, and these we're going to learn in the 7.3 lesson. This is a summary of the rules that we're going to use today. This is on your worksheet. You can keep it handy, print it out so that you can look back and see what the rules are at any time, these 3 rules. So the first one we're going to talk about is when you multiply like bases. These are both the base of 4, and they both have exponents on them. So if we're multiplying 2 of these powers together and they have the same base, then you can add their exponents. And here's why. If we write 4 to the 3rd out, you get 4 times 4 times 4. If you write 4 to the 5th out in expanded form, that means 4 times 4 times 4 times 4 times 4. So altogether you have 1, 2, 3, 4, 5, 6, 7, 8, 4 to the 8th as your all together. So you could just use the rule which you learned about in the Exploring Properties of Exponents assignment in the Week 4 folder. You should have learned that if you have 2 powers with the same base, you can add their exponents. And you can do that even if the exponents are negative. In this example, we have a to the 4th, b to the 5th, a to the negative 2. You cannot do anything with the b to the 5th because it has a different base, but the a's have the same base, so we can add 4 plus negative 2, which is 2, so we would get a squared b to the 5th. And you can write your answer just right next to each other like that. Remember that if you're typing, use this key to say that we have a power coming, or use the formatting tools to actually make it look like an exponent. Here's just another example, 3 to the 5th times 3 squared. You can always go back to writing out the meaning of 3 to the 5th, write it in an expanded form, or you can use the rule which says that you can add the exponents. Here's the rule again. So here's some examples that are not too difficult. Make sure they have the same base, and if they do, you can add their exponents. Always keep the base the same. You never change the base. In B, the 2's are the same base and the 3's are the same base. You might want to rewrite those next to each other. And then you can add the exponents if they have the same base. So we would have 2 to the 2 power, 2 to the 2nd power, times 3 to the 6th power. Here is just a few more examples. We have Q for one base, R for a base, and Q for a base. Remember that you cannot do anything with the R squared because it does not have any other like bases. But the Q's, we could put those next to each other and see that we would have Q to the 3rd times Q to the 6th would be Q to the 9th. And then the R to the 2nd just gets written next to it. In D, we have a negative exponent for our n. Now what about this n? There's no power on this n. Do you know what that would be then? That would be a power of 1. Any base written by itself, any variable written by itself, can have a power of 1. Any number written by itself can have a power of 1 because it wouldn't change the value of it. So if we write these together, we can just add them this way. 3 plus negative 4 would be negative 1. Negative 1 plus 1 is 0. So we're going to have n to the 0, and anything to the 0 power is 1. So here we have that any variable or number written without an exponent actually has an exponent of 1. And you can always add that in there. This is just some practice for you, so you can pause the video, try these on your own paper, and see if you get the right answers. All right, so you should have tried these problems. Let's see if you got 7 to the 12th power for A. And for B, you should have got 3 to the 1st, or you can just write 3 times 5 to the 10th. So 3 times 5 to the 10th is what you should have got. They changed to an X. You don't have to. It's kind of hard to make a dot on the keyboard. I often use the asterisk sign, which is by the 8 key as my time sign. All right, here's another example just for you to practice. So try this and then check your answer. You should have got m to the 5th, n to the negative 4th, or you could write that as m to the 5th over n to the 4th, because then you'd keep the rule of no negative exponents. So some of what you learned in 7.2 you will apply to this lesson as well. Okay, try this one and then check your answer. You should have got x to the negative 7th, which is the same as 1 over x to the 7th. You did not have to do it the way they did. They put these two together and said that's 1. That's one option. But you could also just added all of their exponents, putting a 1 on the one that doesn't have one. 1 minus 1 is 0. Negative 3 plus negative 4 is negative 7. So 1 over x to the 7th would be your final answer. All right, here's another rule. To find the power of a power, you can use the meaning of exponents. So 4 to the 3rd to the 2nd power means 4 to the 3rd times 4 to the 3rd, which means 4 times 4 times 4 times 4 times 4 times 4. So we would get 4 to the 6th. Again, we worked on this with our Exploring Properties of Exponents worksheet. So the rule is that you can just multiply the exponents. So when you're raising a power to another power, you can multiply the exponents. Let's practice. Here we have 5 to the 2nd raised to the 4th power. Now, if you forget what you're supposed to do, you can say, well, that means 5 to the 2nd 4 times. And you just learned that if you are multiplying the same base, you can add their exponents. So you could go 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So this would be 5 to the 8th. Or you can remember the rule that we just learned, which is that you multiply the exponents and get 5 to the 8th. So don't be afraid to write it out in long form to check if you're using the rule correctly. if you're remembering whether you're supposed to multiply or add. Anything to the 0 power is 0, and any base raised to the 0 power is 1. Don't forget about that. So anything to the 0 power is 1. In this one, you'll want to use the power of a power property first, and then we'll do the times x to the 4th. So 3 times negative 5 is negative 15. And then I would add these together and get x to the negative 11th, which then we have to write with positive as 1 over x to the 11th. These are some for you to practice, so pause the video and then come back and start it again and check and see if you got the right answers. So for A, you should have got 3 to the 20th. For B, you should have got 1, because 0 times 3 is 0, and anything to the 0 power is 1. In this one, pause the video again, try this one. It's a little longer, but not too bad. Okay, you should have got, when you simplified this, you should have got a to the 12th times a to the 6th, and then you add your exponents, and you'd get a to the 18th. All right, and here's our last rule for the day. If you have two things being multiplied and they're both being raised to the 3rd power, or any power, you can write out what that means, which is 8x times 8x times 8x, or, and then put your 8's together and your x's together, 8 to the 3rd times x to the 3rd. So the rule is that you apply the power to both of the factors in the parentheses. Each factor will be raised to that power. Now, a lot of times students remember to apply the power to the variable, but they forget to apply it to the number. The number will also be raised to whatever the power is on the outside here. Watch the negatives. In A, the negative is in front, not part of what's being squared. So the negative gets written out front, and then you take 2 squared y squared and simplify that to negative 4y squared. The negative will just be written in front. In B, though, the negative is part of the thing that is being raised to that power. So it would be negative 2 to the 3rd power. In parentheses, negative 2 to the 3rd power. Negative 2 times negative 2 times negative 2 is a negative 8. So we'd have negative 8y cubed. If your numbers are small, like 2's, 3's, 4's, then go ahead and simplify. If your exponent is less than like 5, then simplify that part. If you have something like 17 to the 8th power, leave it like that. Don't simplify when they're big giant numbers, just when they're going to be small numbers. Here's one that's x to the 6th times y to the negative 3rd, all squared. So we have to square the x to the 6th, and we have to square the y to the negative 3rd. So we're going to end up with part of this will go into the denominator, because we'll have x to the 12th times y to the negative 6, and then we write that as that, or more often you'll see it written like this, x to the 12th over y to the 6th. And you can go directly from this step to this step. Here's some for you to practice, so pause the video and then check your answers. So for A, you should have gotten 4 to the 3rd times p to the 3rd. Did you remember to take the 4 to the 3rd as well? And then you can figure out 4 to the 3rd. It's just 64. 4 times 4 times 4. So we'd get 64 p to the 3rd. In B, you should have got negative 5 squared times t squared squared. And negative 5 squared is just positive 25, because negative times negative is a positive. So we'd get 25 t to the 4th. One more example for you to practice. So pause, do the problem, check your answer. In this problem, this one's a little bit longer. You remember that you have to take each factor to that power. So you'll have x squared to the 4th, y 3rd to the 4th, x squared to the negative 4th, y to the 4th to the negative 4th. Now we can simplify each part of that, and we'll get x to the 8th, y to the 12th, x to the negative 8th, y to the negative 16th. When you add these two, when you multiply, you add their exponents. So 8 plus negative 8 is 0. So we'd have x to the 0, and then 12 plus negative 16 is negative 4. But x to the 0 is 1, so that's why the answer is just y to the negative 4th, and then write that with positive exponents as y 1 over y to the 4th. All right, so then there are a bunch of problems for you to practice on your worksheet. Here is some of them. Let's look at, and these are all the properties combined, so you have to figure out what's happening and then use the right rule. Let's look at number 13. That looks like a lot of stuff going on. We have c to the negative 2 times d to the 8th times c to the negative 3. We have some bases that are the same being multiplied. If you want, you can rewrite them next to each other to help you see that they are the same base. And the rule is that we should add the exponents. So we would have c to the negative 5 times d to the 8th. And then we don't want to leave our negative exponent, so we would bring that down below and have d to the 8th over c to the 5th. Now, if you're typing, you can type d to the 8th divided by c to the 5th. It can look like that. Let's look at number 15. The negative is out front. Every factor in this parentheses has to be raised to the second power. So we'd have 4 to the second power, and then we'd have y to the 7th to the second power. And that's going to equal, the negative goes front, 4 squared is 16, y to the 7th to the second power. That's the rule that says if you have a power raised to a power, you can multiply the exponents. So I'd have negative 16 y to the 14th as my final answer. Let's look at the next page. These are the rest of the problems. See if there's anything here that looks tricky. Let's look at number 27. In number 27, we have negative 2, x to the negative 4th times y. Each of these are factors. Each of these needs to be raised to the 5th power. Put the negative 2 in parentheses because the whole thing is being raised to the 5th power. Then we would have x to the negative 4th to the 5th power. Then we would have y to the 5th to the 5th power. Also, it's fine if you want to do your work on notebook paper and then just type the answer in on the worksheet. I know that's tricky to show all of this. So negative 2 to the 5th. Let's see, that'd be negative 2 times negative 2 times negative 2. And you can check this on your calculator, but I believe you get negative 32. Then we have x to the negative 4th to the 5th. The rule is when you raise a power to a power, you multiply. So I would take x to the negative 20th, I would get. And then I would have y, 5 times 5 is 25. And you're not done because of the negative exponent in that term. So now we would leave the negative 32 on the top, leave the y to the 25th on the top, and put the x to the negative 20th on the bottom, which changes the sign of the exponent to positive. So the negative 32 never would get moved to the bottom. Whether it's positive or negative, you don't move the coefficient to the denominator. It stays on top. And then any bases with positive exponents also would stay in the numerator. Only if it has a negative exponent would you move that part to the denominator. All right, I hope you learned a lot and do great on your assignment. Please let me know if any of these are giving you trouble or if you want to just double check. And thank you very much. Have a great day.